No, this is question number 6. This question is from discrete random variable. Ellie has four-sided dice with sides labeled 1, 2, 3, 4. He throws all four dice at the same time. The random variable x denotes the number of twos obtained. Number of twos obtained. Part A of this question is show that probability of x is equal to 3 is equal to 3 over 64. What do you mean by x is equal? Probability of x is equal to 3. This shows that uh, 2 comes on 3 dices. On 3 dices there comes 2. 2, 2, 2. This is fourth is not 2. We will represent not 2, 2 dash. So four-sided dice labeled 1, 2, 3, 4. He throws all four dices at the same time. For example, on first dice 2, on second dice 2, third dice 2, fourth dice not 2. So we have to find to show that probability of x is equal to 3 is equal to 3 over 4, 3 over 64. So first of all, probability of 2 because four fair-sided dice labeled 1, 2, 3, 4. So probability of 2 is probability of 2 is 1 over 4 and probability of not 2 is equal to 3 over 4. Now we have to find actually probability of x is equal to 3. This shows that probability of 2, 2, 2 and on the fourth dice there is not 2. So probability of, now we will write here the probabilities and multiply. Probability of 2 is 1 over 4 and probability of 2 1 over 4 1 over 4 and this is 3 over 4. So we write here the probabilities 1 over 4 into 1 over 4 into 1 over 4 into 3 over 4. But 2, 2, 2 and 2 dash. So there are different arrangements also there of this arrangement 2, 2, 2 and 2 not 2 dash. It may come here also that 2, 2 dash 2, 2 and also there are different uh, options for this, different arrangements of this. How we will find the different arrangements using permutations concept? 1, 2, 3, 4. These are repeated. So 4 factorial other arrangements will be the total arrangements of this 2, 2, 2 and 2 dash will be 4 factorial uh, over 3 factorial. Now we will multiply the answer of this with 4 factorial into 3 factorial because the arrangement of uh, this will be 4 factorial over 3 factorial using permutation uh, concept here. So finally, we get the answer is probability of x is equal to 3 we get 1 over 4 into there are product of 1 over 4 three times, so we can take it in power 1 over 4 power 3 into 3 over 4 into the answer of 4 factorial over 3 factorial. We get using a calculator, or otherwise the answer of 4 factorial over 3 factorial is 4. So we calculate it. When we calculate it, we get the answer is 3 over 64. This is shown. We have to show this, and this is shown. And the next part of this question is now the incomplete probability distribution table is given. This table is called probability distribution table because probability against each value of x is distributed here. This table is called probability distribution table, or simply we can the other name of this is PDF, probability density function. We have to complete the probability distribution table for x. Now there are probability against three values of x are given. We have to find these two probabilities against 1 and 2. So in the same way as we have find probability of x is equal to 3, first we will find the probability of x is equal to 1. Probability of x is equal to 1 mean dice. There are total dice 5 fair sided, four fair sided dice are 4. Only 2 appears on one of those four fair sided dice. This means that we have to find probability of 2 2 not 2 not 2 not. Now again 1 over 4, probability of 2 is 1 over 4, probability 2 dash 2 dash 2 dash are 3 over 4 each. But again, as we have done already, total arrangement just like this, total arrangement of this 4 factorial over 3 factorial. Now the total arrangement of this 2, 2 dash, 2 dash, 2 dash again are 4 factorial. These are total 4. These are repeated 2 dash, 2 dash, 2 dash. So we get the total arrangements 4 factorial over 3 factorial. Now we will find the value of this. After simplifying, we get 1 over 4 into 3 over 4 three times. So we can take the power 3 into 4 factorial over 3 factorial. Using the calculator, we get the final answer, that is 27 over 64. So we write here 27 over 64. Now it is very simple. We will find the sum of these four probabilities of four. We will find the sum of four probabilities, and we will subtract the sum from one. We get the probability of 2, because total sum of probabilities is equal to 1. This missing value we can find 1 minus uh, sum of the remaining. We can get this value probability of x is equal to 2, or other we can also find it as we have find the above probabilities. So uh, probability of x is equal to 2 in the same method above, using probability of 2 2 not 2 not 2. So 1 over 4 into 1 over 4 into 3 over 4 into 3 over 4 But again, the total arrangements of this 2 2 2 dash 2 dash will be 4 factorial using permutation concept 1 2 3 4 4 factorial over 2 factorial. So we will write here also the arrangement total arrangements 4 factorial over 2 factorial and 2 factorial because they are repeated. 2's are also 2's are repeated, 2 dash are also repeated. So now we will simplify it and we'll get 1 over 4 square, 3 over 4 square into 4 factorial over 2 factorial, 2 factorial. Finally, we get the answer is 27 over 128. This is the final answer. 27 over 128. We will write here 27 over 128. This is the probability of 2. X is equal to 2. Now this part B has been completed. Now next part C of this question is find Ex. Ex is the expected value of X or simply mean value of X. Now we will use the above mm, and frequency distribution, probability distribution table to find the value of Ex, Ex expected value of X. This is formula to find Ex. Ex is summation X into Px. We will multiply the values of X and Px, X, Px, multiplying and adding these values. We get Ex, multiplying X values and probability against each X and find the sum. We get it 0 into 81 over 256 plus 1 into 27 over 64 plus 2 into 27 over 128 plus 3 into 3 over 64 plus 4 into 1 over 256. Finally, the answer is this is 0 because of this 0. 27 over 64 plus 27. This is cancel out. 27 over 64 plus 9 over 64 plus 1 over 64. Now finally the sum of these all 64 over 64 that is equal to 1. This is the final answer. Now next part of this question is Ellie throws the 4 dice at the same time on 96 occasions. Now in this question n we have n is equal to 96. Ellie throws the 4 dice at the same time on 96 occasions. Use an approximation to find the probability that he obtains at least twos. He obtains at least twos on fewer than 20 of these occasions. There are multiple concepts in this part. We have to use here the concept of binomial and we have to concept of normal distribution. So this is we can say that this is also the normal approximation to the binomial distribution. So first of all, we have to find the probability uh, at least two twos on fewer than two tools. First of all, we have to find the probability at least two tools. At least two tools. We will take help from this table. At least 2 mean 2 x is greater than or equal to 2x. Probability of x is greater than or equal to 2. This means that 2, 3, 4. We will take help from this table. Probability distribution table. These are the probabilities greater than or equal to 2. This is 2. The probability against 2 is this. Probability against 3 is 3 over 64. Probability against 4 is 1 over 256. So we will add up the probabilities against 2, 3, 4. These are the probabilities against 2, 3, 4. We will add up these probabilities. So we have probability of x is greater than or equal to 2, mean probability of 2 plus probability of 3 plus probability of 4. We get 27 over 128 plus 3 over 64 plus 1 over 256. We get this 60, 67, that is 67 over 256. Now n is given. Ali throws the four dice at the same time on 96 occasions. Use approximation to find the probability that he obtains at least two. Probability we have find on fewer than 20 of these equations. Now we use here uh, normal approximation. Actually, we have to find probability of uh, x is fewer than 20. Probability of x is less than 20, and we have just found the value of probability of success, that is 67 over 256, and is 96. Probability of success is 67 over 256, uh, and q will be 1 minus p, that is 1 minus this value of p. We get this q, the 189 over 256. 1 minus 67 over 256, we get this q. Now actually we have to find the probability of fewer than 20 using approximation. We will use here continuity correction to adjust the inequality sign. Probability of x is less than 20 we have to find. Now after continuity correction it becomes, we will take the lower bound of 20, that is that will be 19.5. Actually we have to find probability of x is less than 19.5. Now we will convert this x into z. X is the normal variable, but we convert it into a standard normal variable, that will be uh, z is equal to x minus mu over sigma. We use here this equation, this conversion, to make this x z. So now probability of z is less than x minus mu over sigma. Now we will find the value of mu and sigma from the binomial distribution. Uh, so binomial distribution, we will find the value of mu and sigma from binomial distribution. We know that in binomial distribution, uh, mu will be n into p. We get mu is equal to n is 96 into p is 67 over 256. After calculating, we get the value of mu, that is 25.125. Keep it in your mind that we will not just rounding off this value to have a good accuracy. So now in the same way, we will find the value of this sigma, that is the standard deviation, by using uh, this formula binomial. Sigma will be n into p into q square root. We get n into p, n is 96 into 67 over 256 into 189 over 256. Uh, Taking square root using calculator, we get sigma is equal to 4.3069. We are not rounding off, just during the working we don't need to rounding off any value. So putting here the value of mu and sigma, we get this probability of z is less than 19.5 minus mu is 25.125 over sigma is 4.3069. After calculating it, 19.5 minus 25 over 0.125 over 4.3069. After calculating, and this we get probability of z is smaller than negative 1.306. Now, this is the value as is negative. We cannot accept the value of z negative, so we convert it into z into positive z. So to make it positive, inequality sign will be changed so that we will write it uh, probability of z is greater than positive 1.306. Now, to use the normal distribution table, we must have a sign of less than here. So we can convert easily by subtracting this value from 1. So 1 minus probability of z is smaller than 1.306. Now we can write it in short form in terms of phi. Phi shows the probability, so we can write 1 minus probability of 1.306. Now we check this value from the normal distribution table. This is the value of z. We will find the probability against this value of z from the normal distribution table. So we get this value 0.9042. 1 minus 0.9042. After subtracting, we get the final answer is 0.95 0.0958 is the final answer. And this is the final answer. This is the probability. Actually, 0.0958.